Hi everyone, Professor Cato here, and I'm in New York City's Central Park. Let's talk about summations, more specific, sigma notation. What's a sum? We all know that. You take an arbitrary number of things and you add them together. Say this one sign, right? And this one fence, plus these three lamps up there. And that becomes what? 1, 1, and 3, which is 5. What happens though when your summation is in a systematic order or counting off, say the natural numbers? You start with 1, right? You start with 1, and then 2, and then right after 2 comes 3. So it has to be in that exact order. What does that look like algebraically? Let's find out together.
Sometimes a summation can be any set of numbers added up together. What happens though when we have the sigma notation where it follows a systematic order? We can see right here under the first definition that we have sigma notation here, yet we still need to label a couple of things. I, in this case, is lower limit. But another way to think of it is a starting point. N is the upper limit. And another way to think of this is the ending point. What is unique to the sigma notation when it comes to summation is that this upper limit can actually be infinite. Though we won't get into that detail today, it's just something to keep in mind because we can have sums that can go on to forever. Yet in this case, we're going to keep it simple and worry about finite examples. The lower limit, another thing to add, is that that's specific to this I that's underneath the sigma notation. And just as a reminder, this is from the Greek alphabet right here. And it's specific to the capital Greek letter of sigma. Let's move on to our second example. Now we can see a summation in sigma notation, and we can establish what those pieces mean. Since I is our lower limit or starting point, that means that we have to start with 1. We're starting with 1, and that means that we now move forward to the algebraic expression, and whenever we see an I, we plug in the number 1 for it. In this case, we see a single I, we plug in 1. Once that 1 is plugged in, as mentioned earlier, sigma notation is unique because it always increases in increments of 1. So now that we have started with 1 and plugged in our 1, we move on to the next number. Well, what's the next number after 1? That is 2. And then right after that would be 3. However, we end at 3 because we can see that the ending point or upper limit is this 3 above the sigma notation as well. Sure, we've listed the numbers 1 through 3. What's unique about the sigma notation is a summation, so there must be plus signs in between them. Now we have not only a sum via sigma notation, which allows us to number off or increment or have incremental growth 1 at a time. And then we sum up the numbers here, which is essentially 6. And that's our answer for example 2. Now that seems straightforward. What happens when the expression behind the sigma itself is a little bit more complicated? Our last example here, we can see that is the same thing, the sum starting from I equals 1 to 3, and instead of simple I, we have I squared now. We start the same way, where we look at the lower limit and we start with whatever number is present, in this case 1. So we substitute our I for 1. But now we have to include every mathematical aspect that the I is being done to. In this case, the square. So we must have I, or in this case 1, squared. Once we're finished substituting as well as done calculating, we move on to the same exact expression, I squared, except for the next incremental growth, which is in this case 2. So not only 2 for substitution, the algebraic expression tells us to do 2 squared, and that's the end of it. If there were more instructions, such as I squared plus 1, or quantity I plus 1 squared, then those would be other examples. However, this is a little bit more simple. Last but not least is the number 3. Not only is it 3, but 3 squared. And notice, and do not forget, that there are addition signs or plus signs in between each incremental growth substituting into the algebraic expression. So here we could do the same thing. 3 squared is 9, 9 plus 1 is 10, and then plus 2 squared is a total of 14. Therefore, we still have a summation, and it is like any other summation where we add things up and we have a total amount. The thing, though, is that this is based on an algebraic expression based on incremental growth. So there's a systematic order of how the numbers will increase as well as how they're being added together.
And that's our summation example. I would say the biggest thing to take away when people are looking at sigma notation for the first time is to realize that the indices are increasing by 1 only. Not 1.5, not 2, not 3. It's always in increments of 1. Just recall the counting or natural numbers. Thanks for tuning in. We'll see you next time. Yeah, your Q is 1. Numbers where you start with 1, then 2,